Hey guys, and welcome to the first live tutorial of computing fundamentals. So the first thing we will start to do is just to give you a review of Sage Math and how you can use it in order to start doing the live tutorials and the further labs. So as you can see here, we have Sage Math running, and this is the Sage notebook, and we have now few active worksheet, as you like to call them. As I said to you before, you might have to watch the video via Google Classroom, or you can go to YouTube, so you can basically chat with me via the chat box available in YouTube. So please go to the YouTube channel and see the live tutorial there, and you can type in and you can interact with me. Okay, so you don't want to go to YouTube, that's fine. You can stay in courses and we can fix later on this issue. So let me start now, and I have very interesting things to do today in Sage, so I hope you will find this tutorial very useful for you. The first thing I will do is to go and create a new worksheet, and I will call it live tutorial 1. And sorry for the sound of the clicks and the keyboard. I try to take them off, but it's impossible because I sit now in a very quiet studio. As you can see, I use the Sage notebook. So you have the Sage Jupyter notebook and the Sage Classical 1 notebook. I prefer to use this one. And there is also another option to use, which is basically cocalc.com, which is the Sage Math cloud. However, I don't think it is good. It's very slow, and maybe using this is much better for doing the tutorials and for doing the lab. After completing this tutorial, you should be able to use Sage Math to draw a graph, and you should be able to use Sage in order to prove a mathematical or theoretical concept. And also I want you to be able to use Sage for evaluating a graph attribute, like how many vertices we have, how many nodes we have. So the first thing you might be asking, how I could find information about Sage here about the graph here in Sage. So we will start typing now the first command. To find out what graphs look like, just type graphs in Sage and then press tab. Now this will give you lots of options, and also this will give you help about the graphs. So if you just want to find out any type of methods and attributes available with the graphs, just press tab, and this will show you lots of help here in the Sage, inside Sage. Now let's say I want to create a complete graph. Press tab again, like this is like an autofill of Sage, and this is complete graph. Now open the left parenthesis. Now you want to know how you can use this method. So pressing a tab key will load a help file, and this help file will tell you exactly what is the definition of this object, which is basically a function, and this complete graph will take the number of vertices as an input, and will return a complete graph. So I will pass now K5, and I press enter, or I press evaluate. Now will create a K5 for me, and it will be also shown here as a picture in Sage. You could just do right click in this to save it for later on, if you want just to save it as an image or as any to upload it to an existing document or so. Now you might also define this complete graph as an object. So I will say, for example, this is K8, this is complete graph, and this is graphs.co complete. You can just type it in or just select it from this menu here, and then I will pass the number of nodes to be 8, and then I could below that just type K8.show. The show method is going to show the graph image as we saw in the previous example. Now this is K5 and it's just has been K8 and it has been shown here as an image. Now I wish you are following me in this, so I will give you time and I will go as slowly as much. Okay, now you join me in YouTube. That's a good news, so you can interact with me. If there is any problem, just let me know, guys. Now let me go back, and I want to show you a very interesting thing that you can do with Sage. In the previous method, what we did is just K8.show, which showed me a 2D of the complete graph in the diagram. Now what if I want to show this KA in a 3D? So I will do show 3D, and then I close the parentheses, and then I will do evaluate. Wait a few seconds because this is going to load a 3D engine and it's going to be a little bit expensive. You can use only show 3D basically from Safari and Internet Explorer. I haven't tried it in Firefox. Chrome definitely is not going to support it. Now this is generate for me a 3D object of Sage. Now I could basically do many things about this object. I could just do let's say I want to draw it in different axes, or I just do, for example, spin on, and this is will navigate it and start to rotate it, so you can really see how the structure look like for a complete graph. It looks really cool and nice to have this feature of 3D in Sage. You can also change the character, you can change the color, sorry, and you can zoom in and zoom out. So if you like to zoom in and zoom out, you can do so and see and have a close inspection of the graph object. Do you have all, guys, Sage now loaded into your VM and you can access the Sage worksheet? If yes, please type in this in the live channel so I can see your feedback. We have lots of time to spend in this tutorial. I'm not going to go very fast. I will take things slowly. until we finish. We have 1 hour, so feel free just to share with me your feedback. Peterson. We know there is a type of graph called Peterson graph. So we select this from the menu. We open the left parenthesis and we wait for the help just to see what type of Peterson graph we could have. Now this Peterson graph takes no parameters. There is no argument. So it's a built-in feature in Sage. We can do more things about it, but we just want to see how the structure of this Peterson graph look like. So I will just make Peterson graph and then I will do .show and then evaluate. Now Sage created a Peterson graph for me. If you want to display this in 3D, you should be able to do so by just typing 3D and evaluate. I really hope the sound is clear, guys, and you don't have any issue with my sound. If you do, please let me know. Now once you create a Peterson graph using the 3D, all you need to do is just to click on that object, right click on it, and you should be able to animate it. And if you look out of the frame, you just like this, you could be able to save that image later on as a picture, and you can upload it to the document. End of the list, you will see I could create a graph using Sage in very simple way. To start, let's say we want to create an empty graph, okay? And because the graph object takes or build something with no vertices, so if you just go and create a new cell, empty graphs, and I will make it just like this. It's an empty graph, so basically there is nothing in this graph yet. The same will happen when I just create a graph with many objects. Maybe there is in Sage an empty graph, so let me look for the help if there is something called empty graph in Sage. Type empty, and yeah, there is an empty graph. As we know, we could just simply ask whether those two graphs are equal, and this equality, it's not the isomorphism of those two graphs, it is the other type of equality. So I could just say if E equal empty, then I just type a normal Python. God, this keyboard is driving me really crazy. Anyway, I'm not going to type F. My laptop keyboard and touchpad just decide today to break down, and it will give me hard time in this live tutorial. Things happen, so apology for that. By next week I should be able to get a new one. So now this E equal empty, it's basically false. It's not a valid comparison to do. Now if you want to build a graph with 5 vertices, what we could do, like if I ask you build a graph with 5 vertices, things are really simple. I just do G and make a new object with the graphs. I keep mixing things today. Graphs, small letter, 5 vertices. Graphs dot tab. Maybe I should create another type of graph. Let's say I will create a wheel. Type W, and this is will create a wheel graph. Here I can see the wheel graph. Open the right parenthesis. It should be able to tell me the help. So this is take number of vertices, and this number of vertices is going to be g.show in order to show this graph, and then evaluate. So this is a wheel with 4 vertices in Sage. Let's say I want to create another type of graph. Let's say I want to create g graph dot cube. Do we have a cube graph? Yes, we do. Cube graph, and the cube will be 4. And immediately, whether you just type semicolon then the variable g, or you just put dot and then the method, and this is will do the show. So this is a cube graph with 4 vertices. In case of cube graph, we are talking about 4 bit strings, so it is more than just only 4 nodes. Here we mean the number of bit strings for the cube graph, and this is maybe the one difference between all graph types. So you have to be careful if I ask you if about defining a cube graph. Let me wait for a few seconds so I can load the 3D to show the cube graph. Here you go. You have now a cube graph, and as I said, you should just be able to save it or to right click on it to spin it. That's spin on, and we can see how this cube graph look like. And when you talk, for example, about dual core CPU, when they say i7, i8, when we mean by dual core, it's how many small CPUs are connected as a cube graph together in order to participate as one single component, one single CPU, so they can increase the CPU cycle of the laptop. And this is what we mean by dual core and so. And all these CPUs are connected in this graph basically in parallel way, so they have the small distance between them, which means increase the computer life cycle. So that was as a cube graph. I carry on now. I want to create a graph with those vertices. Now I want to basically see how this graph look like. So this is a graph I just created. I have a node 0, and node 0 is connected with 1, 2, 3, 4, 5, 6, 7. Here I make just a connection between the sets. Sometimes you just want to create and define each relationship between those vertices. So what you could do, just type g equal graph, open a parenthesis, and now provide those edges as a subset. As you know, a graph is a set of non-empty set of vertices and a set of edges. So this is supposed to create a graph for me where we have the node 0 connected to 1 and connected to 2. Now node 1 is connected to 3 and it is connected to 2, and it already has a connection between 1 and 2. So there is no point to here to put 1 again with the 2. And 2 is connected with 3 and it's already connected with 1, and so. Another thing you could find, now I define this graph as a variable g. I could just simply now see what kind of attributes or method I could apply to g. So g tab, and then you will be able to see loads of options. Let's say I want to add a vertex. Let's say I want to add a vertex. So I will select vertex and I will add vertex number 5. Let's say this is will create a new node, and this is will show it to me as well when I say semicolon g, which means I want to see the output of my g graph. Now this is basically adding another node to Sage. You can just simply add another set of nodes and you can link them, as I will show you in the next example. Sometimes as well you want to make the graph labeled, so you want to label all these edges by the definition of the graph. So you type the command g equal graph 0 to 1, and this is called x, 2 to z, 0 to 2, this is labeled z, and then 3 to a, and then 5 out, which means these the output or the outcome of my graph construction. Now to show the label of these vertices, you have to do something when you deal with the graph in order to activate it by the settings. So when you do add an edge, for example, I have to add now an edge for this graph. I could just simply type the command g add edge between 1 and 2. So let me see now what this will do for me, and then now I just simply do one final check to check that I have now the graph constructed. That should be small g. Now just type here show evaluate. Now it has add a new edge between 1 and 2. Maybe you want to add an edge between 5 to 3. So I will do now g dot add underscore. If you are not sure what you want to type, just write or press tab key, and this will show you the options. I want to go from 5 to 3. Semicolon g, just to write one single command to show and display the vertices of the graph. So this is how the graph looks like now. So this is a graph now where we add a new vertex, and there is so many options you can do. Now just to get a sense of what's happening, all I want you now to do is to check this lab sheet, and we want to do this task. So this is the lab sheet, or what you can call it now the tutorial sheet. So this is how we can add edges, how we can add edges with labels, and how you can add. I will post this to Google Classroom so you can have time to practice and so on. Now type the following and observe the output. Type g equal graph and g add vertex range 10. Type it. I will put it in the chat so you can at least know how to use it. Just copy this command and paste it into Sage. You should be able to see the output of it. To show you, just go back to Sage and right click, paste, and then evaluate. Another thing you could do is to go and try to complete those few tasks. I want to draw a complete graph C, and draw a line graph with 4 vertices, and draw an empty graph, and draw a graph L similar to the following figure. So try to make these out, guys, for today. I could show you simply here in this window now. So if I have graphs and then dot and tab key, there is something called ladder graph, which is not line graph, but Sage deal with line graph as a path. So you could create a path instead of creating a line graph. So my advice for you is just to look for a graph dot path. So look, now it's generated, and this is a ladder graph. Let me go back now to the lab sheet so you can see what I want you to do. So we want to do a complete graph, a path or a line graph with 4 vertices, and then we want to do an empty graph, and we want to draw a graph similar to this lab here we have. Maybe I just zoom. So this is the graph we want to draw. If you want the actual lab, I can post it now in courses, so you can read it and apply it. Now a few commands, they might not work in the cloud. Just tweak them. Normally G capital and G small is the issue, so just tweak that and you will be able to find your way in the tutorial. To the following figure in the lab sheet, if you just want to do an extra task just to practice and understand how Sage deal with it. Now remember, when you create the graph, you have to pass label equal true in order to show the labels in those graph. And don't worry about the lab report, because there is no lab report for this week, and I will see you next week in the lab. If you have a question, please post it. Anyway, thank you guys for joining me. This is like a mock lecture. We try if this method is useful and helpful. If it's not, you can tell me this next week in the lab. We have a lab, and it's going to be a graded lab, so you should all attend, and I will discuss with you the efficiency of this live tutorial. Apology, because a new keyboard, a new mouse, I'm carrying so much equipment just to make this live tutorial happen, but at least you have now the sense of Sage and graph in Sage. Thank you for watching, and see you next week.